Case study, SecureX's journey, enhancing cybersecurity with AI through theoretical foundations, robustness, and compliance. In cybersecurity, leveraging AI models to predict and mitigate threats is not just a possibility, but a necessity. This case study dives into the intricacies of applying theoretical foundations to AI in cybersecurity, following a tech firm named SecureX that specializes in developing AI-driven cybersecurity solutions. SecureX was founded by Dr. Emily Carter, a renowned expert in artificial intelligence, and Michael Lee, a cybersecurity veteran. Their mission was to integrate AI and cybersecurity to combat the increasing sophistication of cyber threats. One morning, Emily and Michael were in the middle of a board meeting discussing their flagship product, Sentinel AI, an AI system designed to detect cyber threats in real time. Emily began by emphasizing the importance of solid theoretical foundations in the AI models they were developing. Our AI models must be robust and reliable. Without a deep understanding of the theoretical principles, our models are just black boxes prone to failures, she said. This statement caught the attention of the board members, prompting Michael to delve deeper into a recent incident they faced. Sentinel AI had incorrectly flagged a benign software update as malicious, causing a temporary halt in operations for one of their major clients. The misclassification was traced back to an overfitting issue in their deep learning model. Overfitting occurs when a model is trained too well on its training data, capturing noise instead of the actual patterns, leading to poor generalization on new, unseen data. This situation raised a crucial question. How can SecureX ensure their models generalize well to new data, preventing false positives or negatives? Emily suggested implementing regularization techniques to penalize overly complex models, thereby reducing overfitting. Additionally, utilizing cross-validation techniques could help in assessing the model's performance on different subsets of data, ensuring the results are not due to random chance. The conversation then shifted to adversarial attacks. Michael highlighted a potential vulnerability. Adversarial machine learning is a significant threat. By slightly altering input data, hackers can deceive our models into making incorrect predictions. He referenced Goodfellow et al.'s research on adversarial examples, which demonstrated how minimal perturbations in input data could lead neural networks to make wrong classifications. This discussion led to another critical question. How can SecureX develop more resilient models capable of withstanding adversarial attacks? Emily proposed integrating adversarial training into their model development process. By training models on both regular and adversarial examples, they could improve the model's robustness. Also, exploring advanced techniques like defensive distillation could help mitigate the impact of adversarial perturbations. This approach involves training a secondary model to be less sensitive to small changes in input data, thereby enhancing resilience. As the meeting progressed, one board member asked, "How do we ensure our AI models are not just accurate, but also interpretable?" The importance of model interpretability and explainability cannot be understated, especially when decisions need to be transparent for compliance purposes. Techniques such as LIME and SHAPE can provide insights into the factors influencing model predictions, making the decision-making process more transparent. Michael pointed out that while these techniques were valuable, integrating them into Sentinel AI would require a thorough understanding of their theoretical underpinnings to ensure reliable explanations. This led to another fundamental question. How can SecureX balance the complexity of AI models with the need for interpretability and transparency? Emily suggested a hybrid approach, combining simpler models for interpretability with complex models for accuracy. By using interpretable models in the initial stages to filter out obvious threats and employing more complex models for nuanced decisions, they could strike a balance. Additionally, leveraging SHAP values in complex models could provide a clearer understanding of feature importance, ensuring transparency without compromising on performance. The meeting then addressed the security of AI models against various attack vectors. Michael mentioned that AI models must be resilient to evasion, poisoning, and inference attacks. Evasion attacks involve manipulating inputs to bypass detection, while poisoning attacks involve injecting malicious data during training to corrupt the model. Inference attacks aim to extract sensitive information from the model's outputs. These issues raised a vital question. What strategies can SecureX employ to safeguard their AI models against these diverse attacks? Emily recommended adopting differential privacy principles, which help in protecting sensitive information while still allowing for the training of AI models. By incorporating techniques like noise addition and data anonymization, they could enhance the security of their models. Furthermore, employing robust anomaly detection systems could help in identifying and mitigating potential poisoning attacks during the training phase. SecureX also faced the challenge of adhering to standardized protocols and frameworks for AI in cybersecurity. One board member asked, "How can we ensure our AI solutions comply with industry standards and best practices?" Standards developed by organizations like the National Institute of Standards and Technology provide guidelines for the reliable and secure use of AI in cybersecurity. Adhering to these standards would involve regular audits, thorough documentation, and continuous updates to align with evolving best practices. Emily emphasized the importance of a solid framework for understanding existing knowledge and identifying research gaps. By fostering a research-driven culture, SecureX could stay ahead of emerging threats and continuously innovate their solutions. This approach naturally led to the question, how can SecureX foster an environment that encourages research and innovation in AI and cybersecurity? Michael suggested establishing partnerships with academic institutions and research organizations to stay abreast of the latest developments. Additionally, encouraging internal research initiatives and providing resources for continuous learning could drive innovation. Creating a dedicated research wing within SecureX would not only advance their knowledge base, but also provide a platform for testing and validating new theories and techniques. Concluding the meeting, Emily and Michael reiterated the importance of grounding their AI and cybersecurity practices in solid theoretical principles. They acknowledged that while the journey was challenging, it was essential for maintaining the efficacy and security of their AI systems. To summarize, the key takeaways from SecureX's discussion include the importance of ensuring model generalization to new data, developing resilient models against adversarial attacks, balancing complexity with interpretability, safeguarding models against diverse attacks, adhering to industry standards, and fostering a research-driven environment. Each of these aspects is vital for the robust development and deployment of AI systems in cybersecurity. By regularly implementing cross-validation techniques and adopting regularization methods, SecureX can prevent overfitting and improve model performance on unseen data. Integrating adversarial training and advanced defense mechanisms can enhance model robustness against adversarial attacks. Utilizing model interpretation techniques like LIME and SHAP ensures transparency and compliance. Incorporating differential privacy and anomaly detection can secure AI models against various attack vectors. Adhering to NIST guidelines and best practices ensures compliance and reliability. Finally, fostering a culture of research and innovation keeps SecureX at the forefront of AI and cybersecurity advancements. These strategies, grounded in solid theoretical principles, provide a comprehensive framework for enhancing the security and resilience of AI systems, ultimately contributing to a safer digital landscape.